Hi, this movie is for Learning Target 4, and this deals with circles and arcs. So we did the warm-up looking at arc length, the fraction of the length. We also learned how to name an arc and how an arc, such as arc AC, is congruent to its central angle measure. We labeled minor arcs with 2 letters, semicircles with 3 letters, semicircles going halfway around the circle, and major arcs, meaning more than 180, with 3 letters as well. Arc measure, which we are adding to page 43 of your handbook, is the measure of a minor arc. It's equal to the measure of its corresponding central angle. So the minor arc, RT, has a central angle of 50, so is equal to the measure of angle RST, which is 50. The major arc here, TQR, which goes around the outer edge, is 360 minus the 50, so that's 310. So arcs have measures to them, and the measure of an arc is equivalent to its central angle. Pause the movie, add that to page 43, and then press play when you are finished. Okay, this is not in your handbook, but it makes sense. Arc addition postulate says, in order to get the arc ABC, we would take the arc AB and add it to the arc BC. This is like the segment addition postulate or the angle addition postulate. Let's look at this example. What is the measure of each arc? So if I'm looking at arc BC, which is right here, it's equivalent to its central angle. So that is 32 degrees. If I look at BD, that is this entire arc. Therefore, it is 32 plus the 58, because if the arc CD is 58 degrees, then the central angle is 58 degrees. So I do 32 plus 58, and I get 90. That is using the arc addition postulate. ABC means that I'm going by A to C by direction of B. Now, if CA is a diameter, cutting this in half, we can see that ABC is a semicircle, so that's going to be 180 degrees. AB would be my 180, subtract off the 32, so I get 148. Pause the movie, try this one on your own, and press play when you are finished. Okay, let me give you the answers to these. We had 77 degrees, 103 degrees, 208, and 283. And you can check yourself. Circumference of a circle is the distance around the circle. It acts like the perimeter, it's just we call it circumference since we don't have sides. The number pi is the ratio of the circumference of the circle to its diameter. Pi is an irrational number, so we use pi, it's exactly pi, or we use an approximate 3.14. So keep that in mind, because we want exact answers sometimes, and we'll put answers in terms of pi, or we want approximate answers, and we'll round our decimal. So circumference of a circle. Add this to page 43. And the formula is, I like to say, C de pi. If you see de pi, you eat de pi, right? C equals D times pi, or pi times D. C de pi, eat de pi. So that is circumference. Now diameter is also known as twice the radius. So you also see that circumference is 2 pi r or 2 r pi. You can put that either way. So multiple formulas there. But pause the movie, add that to 43, press play when you are finished. Okay, many properties of circles deal with ratios that stay the same no matter what the size circle is. This is because all circles are similar to each other. You need to know that. If I took circle O and I translated it over to circle P, I would have circle O here, O prime. And then if I dilated circle O about P, then I would get the circle P. So you can see that all circles are similar to each other. There also exists the dilation with a scale factor of K over H. That gives us the scale factor that will map circle O to circle P. So a translation followed by a dilation is a similarity transformation. It does not mean rigid motion since a dilation does not have rigid motion. These we call concentric circles, where they share the same center point. Coplanar circles are circles that have the same center and called concentric. Let's look at this example. A car has a circular turning radius of 16.1. That's what this length is. The distance between the two front tires is 4.7. That's this length. So if we wanted to get this distance here to the outside, we could subtract those and we get 11.1. So the radius to this circle is 11.1. The radius to the outer circle is 16.1. And how much further does a tire on the outside of the turn travel than the tire on the inside? Well, the tire on the inside is going to go across the circumference, which is 2 pi r, or diameter times pi. Because I'm given the radius, I'll do 2 times pi times my radius, and the inner circle is 11.1. That's 69.74. And then a tire on the outside will have a circumference of 2 pi times 16.1, which is going to give me 101.16. And when I subtract these two, 101.16 subtract 69.74, I get about 31.42 feet. Wow, that's longer than I thought. So a tire on the outside is traveling 31.42 feet more than the inside. The measure of an arc in degrees is what we call an arc length. It's a fraction of the circumference. So we know that circumference is all the way around, but what if we only wanted to do a certain arc length, such as this arc length here? Well, if I knew the central angle, then it's a fraction of the whole circumference. And that's what we're going to look at now. Please add this idea of arc length to page 43. And it basically means that you take a fraction of the circumference. The length of an arc of a circle is the product of the ratio, which is the fraction, and the circumference of the circle. So I take my central angle divided by 360, because 360 would be all the way around, and then times my circumference. So add that to your handbook. Now let's practice arc length. So in this one, I'm finding the arc length of the red arc, which is arc XY. My central angle is 90 degrees, and I know that my radius is 8. How do I know that it's 8? Because the diameter is 16. So I could use that the diameter is 16, or I could use that the radius is 8, and this is inches. But what I know is that my arc length, what is the length of the arc? Arc length is going to be 90 out of 360. That's my fractional part of my circumference. And my circumference is diameter times pi. So this is essentially what I'm doing. If I multiply my numbers, I get exactly 4, because this is 1/4 times 16. I get 4 pi inches. That is my exact arc length. That is my arc length. It says in terms of pi. That means give me the exact, and that's what this is, in terms of pi. My approximate would be, is if I do 4 times pi, 12.57 inches would be my approximate. Take B, Find the arc length, the exact, and the approximate. All right, you can see that we're going all the way around this way. And that's 240 degrees out of 360 times my circumference, which is diameter times pi. Diameter is 30 times pi. So if I multiply everything but pi, I get 20 pi centimeters. That is my exact answer in terms of pi. Now, if you type that in, you'll get approximately 62.83 centimeters. So you need to know how to write your answers in terms of pi. So make sure you're able to do that. Pause the movie, try this on your own, and press play when you are finished. Okay, in this one, we are looking at the length of a semicircle. So it's halfway around with a radius of 1.3. So that gives me a diameter of 2.6 meters. And it says to leave my answer in terms of pi. So my arc length is going to be 180 out of 360. That's my fractional distance. Times diameter times pi. And so that's going to give me 1.3 pi meters. You type everything in, but the pi, you leave that out. And you get 1.3 pi meters. And that is the end of this movie. Thank you for watching.